In this 3 steps to sketch, we're going to tackle a method for graphing one of the more complex trig graphs, shifted cosecant graphs. So these will be in the form y equals a cosecant of bx minus c plus d. So you can see the shifts there are c and d. We'll talk more about those in our method description. First, a couple of notes. 1, this method hinges on the fact that we know cosecant is the reciprocal of sine. And so we are actually going to use our knowledge of graphing shifted sine graphs in order to graph its reciprocal cosecant. There are, of course, other methods for graphing cosecant. You can just use the parent function and apply transformations. But since you likely already know how to graph sine graphs, you may really prefer this method. One other note, this method is for shifted cosecant graphs. And so if you're familiar with how to graph the basic cosecant graphs, and I will link to that in the video description, then this will feel very familiar with one additional step to account for the shifts. All right, so here's the method for shifted cosecant graphs. Step 1, you'll find the companion equation and all of its essential information. Step 2, we're going to plot that companion pattern and then shift it. And in step 3, we'll create the reciprocal graph. We'll sketch that cycle and then repeat. So now to dig into each of these steps in detail. And I will have a template at the end so that you can use that template for any of your shifted cosecant graphs. All right, so digging into step 1, find the companion equation and all of its essential information. So here's our original general form equation for cosecant. Your companion equation, like we mentioned earlier, is going to be the shifted sine equation. So here's that general form, y equals a sine of bx minus c plus d. So essentially you're just switching out the cosecant function for the sine function, and then you're going to find all the essential information for sine. Okay, so let's just take a quick look, remind ourselves what that is. We'll start by analyzing a, b, c, and d, knowing that b and c are going to give us our horizontal transformations. B tells us how many cycles happen between 0 and 2 pi for your particular graph. You also use B to calculate the period or the length of a horizontal cycle. Calculate that with 2 pi over B. And then you find the phase shift or the horizontal shift dividing C by B. So that's the new piece that you haven't done. The rest of it should feel familiar from your unshifted cosecant graphing or your unshifted sine graphing. All right, the vertical transformations are A and D, and if you take the absolute value of A, you'll get the amplitude of that companion sine function, which will help, we'll see in later steps, set the local maximum and the local minimums for the cosecant function. And D will give us our vertical shift. After you've done all of that analysis, you can choose scale labels. And we do this very intentionally for the horizontal scale in particular. Take the period and divide by 4. And that ensures your 4 key pieces of the pattern for both the sine and then when you take the reciprocal cosecant will align nicely with your horizontal tick marks. You may have a little bit of a difference with the shifting, but it'll establish a really solid initial scale. And for your vertical scale, likely 1 will work. So the last piece for your analysis, I like to find the asymptotes for your actual graph, so for that cosecant function. And there's a really easy way to do this. All you need to do is take the horizontal transformation or the inputs of the cosecant function, so that bx minus c, and you set it equal to 0 plus pi k. Then you'll solve for x, and we set it equal to 0 plus pi k because those are where the original zeros for that companion sine function happen. And when you take the reciprocal of a 0, you end up with a vertical asymptote. So those are your vertical asymptotes for cosecant. Essentially, you're applying the horizontal transformations to the parent asymptotes of cosecant x. I do have a video that goes into a lot more detail on this and has an example worked out as well, so I'll be sure to post that link as well. One final thing, notice that k is an integer. More details in that video I just referenced. All you have to do is substitute in different values for k and you'll get different asymptotes along your graph. So that's step 1. That's a lot of analysis. This is a big method, a big process, but getting organized and analyzing first is really important because it makes all the other pieces fall into place. So let's take a look at step 2. So step 2 is to plot that companion equation pattern and then go ahead and tackle those shifts. So that's again the general form of the equation. And a quick tip here, we are graphing the companion function. We mentioned that in step 1, y equals a sine of bx minus c plus d. So do this in a different color is my tip. This will not be your final graph, but you'll use it to get then finally to your reciprocal graph that you want. All right, and that'll be in step 3. So our companion pattern, you may recall, for sine graphs is first 0, maximum, second 0, minimum. Okay, and a little more detail on that. Your first 0 starts at the origin. This is before shifting. Then, because of how we set up that horizontal scale, remember we took the period and divided by 4, your maximum will happen at your first horizontal tick mark. The y-coordinate will come from the a of your equation, your companion function. Your second 0 will happen at the second horizontal tick mark, and your minimum will be third horizontal tick mark, opposite value of a. And so this is if your a is positive. If you have a negative out front, that indicates you have a vertical reflection. So the pattern flips on its head, and the only adjustment is you'll notice that the minimum and maximum get relabeled. You can still follow this guide right here. All of that will still work. You'll just notice you're graphing 0 minimum, 0 maximum, because that shape flips on itself over that x-axis. Okay, so after you lightly plot your companion pattern, then you can go ahead and shift it. So remember that your shifts come from C over B for that horizontal or phase shift, and your vertical shift will come from your value D. Usually you can apply these shifts to your companion pattern points at once. You can do both at the same time, and then you'll have your final companion function that you can move on then to step 3. So in step 3, we recip, or take the reciprocal, change it to the reciprocal function with a quick transformation. Then we'll sketch the first cycle and repeat for as many as we need. All right, so to create the reciprocal graph, you just need to know how to translate that companion graph. So we do that as follows. The first 0 becomes the first asymptote for the cosecant function. So wherever your shifted 0 ended up, you'll change it into an asymptote, and you'll be able to do this in your final color. Your maximum from your companion graph will become your local minimum for your cosecant graph. The second 0 will become your second asymptote. Those are vertical asymptotes, of course. And then your minimum for the companion graph will become your local maximum for the cosecant curve. Once you've made those translations or done the reciprocal change, you'll be able to sketch your graph. So we'll take a quick look at what a cosecant graph should look like, or just put that into an online graphing calculator, y equals cosecant x, if you're not familiar. And then you'll repeat for as many cycles as you need. So it's a big method, but 3 steps. You'll keep everything organized and in place, and you'll be graphing cosecant graphs that are shifted like a pro. So here is the template that I mentioned before. Again, it is lengthy, but this is one of the more advanced trig graphs that you'll probably see. So I like to do this template for every single example that I work, and I will post a lot of examples, so be sure to check those out. But you can see everything that we just talked about is organized in a very consecutive and strategic order. So all the steps there. Without working through a very specific example, I just want to show you this process going through. So we're just going to assume that we found some companion equation. Let's say here are our tick marks. So what you would do, and let's just say A is here and here is negative A. So you would lightly sketch your initial unshifted companion graph, the y equals a sine bx. So that's your companion graph without the shifts. Then you apply the shifts in step 2. So let's say we moved right 1 grid unit and up 2 grid units. So we'd be here, showing with x's. We're just doing this so you get an idea of what this is supposed to look like. So shifting everything, I'll shift right and up 2. So this would be your shifted sine graph right here. Of course, that's not our final graph. We're trying to graph cosecant. So from here, you'd be in step 3 and you'd be creating the reciprocal graph. So see our first x in the dark blue, that was our original 0. I called it 0, 1. So that will become our first asymptote. A quick note here, you'll be able to use that asymptotes equation that you found in step 1 to double check the location of your asymptotes. Okay, we know that our maximum turns into a local minimum. Our second 0, 0, 2, turns into another vertical asymptote. Our minimum turns into a local maximum. And then you'd start a new cycle here with another vertical asymptote. You would sketch in. Here's what a cosecant graph looks like roughly. Graph it in around those asymptotes. And here would be one cycle of a shifted cosecant graph. Of course, you would repeat that pattern for as many cycles as you wanted. I'm not going to show that here, but again, I will post many, many more examples of shifted cosecant graphs, so be sure to check those out. Hopefully this method gives you something to anchor to, a way to stay organized, and to create really nice, accurate sketches of shifted cosecant graphs. Again, be sure to check all the links in the video description. There will be a lot more resources there, and good luck. Thanks so much for watching.